Good morning students, welcome back. This is Dr. Thulasi, working as Associate Professor in the Department of Computer Science and Engineering, VNITSW Institute of Technology and Sciences for Women, Palakaluru. In the last session, we have seen second unit. The contents of the second unit are the classes and objects, the nature of the object, relationship among objects, nature of class, relationship among classes, interplay of classes and objects, identifying the classes and objects, importance of classification, key abstractions and mechanisms. These are the topics which we have covered in the Unit 2. And in today's session, we are going to discuss the Unit 3. And the contents of the Unit 3 are Introduction to UML, Why we model, Conceptual model of the UML, Architecture, Classes, Relationships, Common mechanisms, Class diagrams and Object diagrams. And coming to the session, let's start the basics of the unit as usual. Let me start with the question, what is UML? And the name says it's all. UML stands for the Unified Modeling Language. Unified Modeling Language is an open standard graphical notation for system development proposed by Object Management Group. Object Management Group is a consortium of software. The notation is based on work from Grady Butch, James Ramba, Yvonne Jacobson. And UML is a modeling language to express and design documents, software particularly useful for the object-oriented designing. The language can be used from general initial design to very specific detailed design across the entire software development lifecycle. And the Unified Modeling Language is a graphical language for modeling and developing of software systems. The UML diagram become a common work product for developers use to discuss all the phases of the software development. We have seen in the first unit the phases of the software development, and the UML is used for all the phases in the software development. It means requirements gathering and analysis, design, implementation, testing, deployment and maintenance. The goal here is to model the software system before we build it. Unified Modeling Language is a modeling language that combines various approaches in a single design language, which is used to plan and create computer applications. UML is actually a combination of several notations. That means object-oriented design, object modeling technique, which is also known as OMT, and object-oriented software engineering, OOAD. The Unified Modeling Language is a family of graphical notations backed by a single meta model that help in describing and designing software systems, particularly software systems built using object-oriented style. It means by using OOPS concepts. And this is regarding the brief introduction regarding the UML. And let me tell you why to use this UML. What is the use of UML? We all know that a picture is worth 1,000 words. This item absolutely fits describing UML. Object-oriented concepts were introduced much earlier than UML. At that point of time, there was no standard methodologies to organize and consolidate the object-oriented development. It was then UML came into the picture. There are a number of goals for developing UML, but the most important is to define some general purpose modeling languages which all developers can use, and it also needs to be made simple to understand and use. UML diagrams are not only made for developers, but also for the business users, common people and anybody interested to understand the system. Here, the system can be a software or a non-software system. Thus, it may be clear that UML is not development method, rather it accompanies with the process to make it a successful system. The goal of UML can be defined as a simple modeling mechanism to model all practical systems in today's complex environment. And it's a widely used modeling language in the field of software engineering. As the software architecture grows in size and complexity, so does the need for the software models came into existence. UML is the software industry's dominant modeling language. It is currently a de facto standard adopted by the Object Management Group, which is the world's largest software consortium, And it is difficult to find a software project with more than 10 developers who do not use UML in some way to specify their architecture. Here is some more other facts for using UML in our software development process. Let us discuss them in brief. Software is getting increasingly more complex. A pretty old version of Windows XP having 40 million lines of code. A single programmer cannot manage this amount of code in its entirety. Code is not easily understandable by developers who did not write it. So we need to simplify the representation of the complex systems. So we need simpler representation for complex systems. So we use modeling to do this activity. So we need simpler representation for complex systems. So modeling is the best choice for this. Modeling is very simple to deal with complexity. UML is an open standard graphical notation for specifying, visualizing, constructing and documenting software systems. Modeling language can be used from general initial design to very specific detailed design across the entire software development lifecycle as we discussed earlier. UML increases the understandability and communication of product among stakeholders. That means they might be the customers or the developers or the users of the system. It also supports diverse application areas like air traffic control, animation, business or instance, business data processing, etc. There is a lot of support for UML in many software packages today, like Rational Rows, plugins for popular IDE, integrated development environment like NetBeans, Eclipse. These have the compatibility with the UML. Based upon experience and needs of the user community, the usage of the UML also varies. The Unified Modeling Language is a graphical language for OOAD, Object-Oriented Analysis and Design, that gives a standard way to write a software system's blueprints. It is used to depict the structures and the relationships in a complex system. This is regarding the why we are going to use this UML. So these are some of the advantages of using this UML. And coming to, we have seen the word model all the times. So let us discuss what is this model. A model is a simplification of reality. A model is an abstraction of the real thing, leaving out details. The collection of all the elements that describe our system, including their connections to each other, make up your model. When we use UML to create models of a system under development before we code the software, they represent the problem in a simplified way. They provide a structure for problem solving. They help in understanding how one can proceed with the problem at hand. They also allow to experiment with the multiple solutions, since the models are created before the actual development of the system. We can understand different possibilities, problems, options, etc. by using this modeling. And this also leads to the decrease in the development cost, because in the olden days we used to develop all the system many number of times, so that leads to the increase in the development cost. By using these models, this reduces the development cost. Since the time will not be wasted in trials and errors, the product will be ready in lesser time. Models also help manage the complexity of the problem, so the planning of the development, allocation of the resources like machines, programs, testers can be done easily. So this is regarding the model. In brief, I can say model is a simplification of the reality. And why we need to model? So there arises a question, why we need to model? So we need to model to analyze the problem domain. It is simplify the reality, capture the requirements, visualize the system in its entirety, specify the structure and behavior of the system. And we can design the solution, document the solution in terms of its structure, behavior, etc. We build models to better understand the system we are developing. We build models of complex systems because we cannot comprehend such a system in its entirety. Modeling achieves 4 aims. Modeling helps us to visualize a system as we want it to be. So you can see in the PPT, visualizing a picture is worth a. You can see in the PPT, here visualizing means a picture is worth 1,000 words. a graphical notation, articulates and unambiguously communicates the overall view of the system. It means overall view of the system is nothing but it can explain clearly about the problem domain. Next, modeling permits us to specify the structure or behavior of the system. Here, the specifying means UML provides the means to model precisely, unambiguously and completely the system in question. Next, modeling uses a template that guides us in constructing a system. Here, the constructing means models build the UML have a design dimension to it. These are language independent and can be implemented in any programming languages. Modeling helps to document the decisions we have made. It means documenting every software project involves a lot of documentation from the inception phase to the deliverable phase. So what is meant by inception phase? We'll see in the later part of the unit. And coming to the next one. Most manufacturing and building process requires the creation of a model before the actual product is created. So you can see in the figure models in architecture. It means the UML diagrams or models can be used in the field of architecture. Here you can see some of the architectures. And coming to the next one, it can be used in the automobile models also. You can see the pictures in the PPT. Here you can see the car picture, and here you can see some of the pictures which are used in the automobile industry. Next, why modeling is important? What is the use of using this modeling? So, first point is for better communication among stakeholders. It means modeling helps us to bring all the stakeholders to a single platform. And next one is for documenting high level design decisions. It means if you want to go from the low level also we'll use the UML diagrams. For high level also we'll use the UML diagrams. Here for documenting high level design decision also we use this UML. This is the use of the importance of the modeling. Next, for risk reduction. For risk reduction means in the figure you can see that if people do not know the swimming, then they wear safety coats to avoid risk during the traveling through water. So here also, if you want to know what the model can do without a total construction. So this is so that we can avoid the risk. This is the use of using this modeling. And next one. Next one is for what if analysis. What is meant by what if analysis? What if analysis is the process of changing the values in the cells to see how those changes will affect the outcome of the formulas of the worksheet. So before implementing, we can just go with the trial and error method so that will be easy for us whether to proceed or not. This is the meant by what if analysis. That can be done by using this modeling. Next one is it allows reuse of design components and patterns across projects. So we can use many number of components. The main goal of using this object-oriented programming is the simplicity and the reusability. So we are using the same concepts of object-oriented so that we can reuse the design components in next part of the designing also. So this is the use of using this modeling. And if you don't do modeling, you may have to cry. So that is shown in the PPT. Next one. What UML is not? It means what is not a UML. So what is, if we know what is not an UML, we will know what actually UML is. So let us see what UML is not. UML is not a notation. As I told you that UML is not a notation. It is a language. UML is not owned by anyone. It is open to be used by anyone who wishes to use it. It is not proprietary. UML is not a process or a method. UML encourages the use of object-oriented techniques and iterative software development lifecycle. UML is not difficult. It is large. But one need not know it entirely. Also, there is no need to use or understand every small thing in it. UML is not time consuming. If properly used, use of UML cuts down the development costs. At the same time, it gives the advantage of easily understanding and communication increased productivity and better quality. UML is not limited. It is flexible enough to allow newer vocabulary like concepts, words and terms. Properties. It means additional information about the things. And semantics. It means semantics are nothing but the rules which are used in the language, which are required for a specific domain. This is regarding what UML is not. Coming to the objectives of the UML. A visual modeling language and not a visual programming language. It means the UML is a visual modeling language. It's not a visual programming language. As we discussed from the earlier part also, everything we are saying that UML is a modeling language. It's not a programming language. Although some modeling tools have code generators and some can reverse engineer models from code. Isn't it? As I told you that the forward engineering means from model to the generation of the code, and the reverse engineering means from code to the generating to model. This can be used in the UML also. It is intended to create diagrams that can support the software development process. However, UML is not a software development process or a development method. Therefore, UML is a process independent. A standard language for creating software blueprints. It's a communication tool to communicate among the stakeholders. A language for documenting requirements, architecture, tests, project planning, etc. It is intended for software systems but can model other systems. It is intended to support the object-oriented development process. It can capture both static structures and dynamic behavior of the system. Here, the static structure can be implemented by using the class diagrams. Dynamic structure can be represented by using the state chart diagrams and the activity diagrams. That can be done by using this UML. UML diagrams can help stakeholders understand, discuss and agree on the requirements. Okay. It means by showing the modeling diagrams, we can bring all the stakeholders to a single platform and discuss about the project so that we can bring them to a common decision about the project. UML diagrams can help abstract complicated processes to a level that is easier to understand. UML diagrams help facilitate problem solving. So this is regarding the brief advantage of using this UML. So what does a modeling language provide? So what are the main things that a modeling language can provide? It means first one is it can provide elements which are used to model. Here also the UML can provide concepts and semantics. So that will be easy to develop the models in the UML. Next, it can provide notations. It means visual rendering of the model elements. It can provide some guidelines. It means what are the common modeling techniques which we are going to use. Hints and suggestions for using these elements in the notation. This is the things which the modeling language can provide. It means here the modeling language is nothing but the UML language. The UML language can provide the model elements, notation and guidelines. Next, coming to the brief history of the UML. So let us see the history. Back in the late 80s, when we started modeling, there were many different methodologies and each methodology had its own notations. The problem was that if different people were using different notations, somewhere along the line, somebody had to do a translation. Okay, a lot of times one symbol meant for one thing in one notation and same thing totally different in another notation. So in 1991, everybody started coming out with the books. It means they had published their works. Here, the Grady Booch came out with his first edition. Ivar Jacobson came out with his, and James Ramba also came out with his object modeling technique. As in short, I told you that object modeling technique, which is specified as OMT methodology. Each book has its own strengths as well as its own weaknesses also. Object modeling technique was really strong in analysis but weaker in design. The Booch methodology was stronger in design but weaker in analysis. And Ivar Jacobson's object-tree was really good with users' experience, which neither Booch nor OMT really took into the consideration back then. Booch-Jacobson merged the two methods in 1994 and then Ramba joined in 1995. UML 1.1 was published in 1997 from Object Management Group. As I told you, which is a world's consortium for software. So which included the inputs from other publishers also like UNIT, etc. So the UML version 2.x is the most current version which we are using now. So coming to the release dates, here we are having some versions and the release years of the UML. So the UML started in 1995 with the UML 0.8, and next in 1996 it came with the UML 0.9. Here the three amigos, it means the three amigos are nothing but the Ramba, Grady-Buch and Jacobson. They three combined their technique. In 1997, OMG takes over. In 1997, OMG UML 1.1 came. So why the OMG taken over means they had added the inputs from UNIT or some other publishers who had given good inputs to the UML. And in 1998, UML 1.2 has been started. In 1998, OMG has developed UML 1.3. In 2001, it came out with the UML 1.4. In 2003, with the UML 1.5. In 2003, 2.0 also released in the same year, and which is the adopted version. And 2005, UML 2.0, which is the final version. And 2006, UML 2.1. And UML 2.1.2, which came in the 2007 year. And current version is 2.x, that is released on 27/5/2008. So you can see the figure in the diagram. So if you go through the figure, here we have used three methods: Buch OOAD method and OMT, object modeling technique, OOSC, object oriented software engineering, and other methods were combined, and it produced the unified method 0.8. Next, the other methods, again it was undertaken by the OMG, and it combined with the other methods. And next development is UML 0.9, and next UML 1.0, that is the standardization. Next 1.1, and again we went for the revision, and for 1.3 onwards we had gone for the industrialization. Now the current version is UML 2.0. That is what you can observe from the figure also. So next, coming to the, what is the motivation behind these three people combined their work? It means Grady-Buch, Yvonne Jacobson, James Ramba. They had combined their work. Why? What is the motivation behind the unification? So fact that individual methods evolving towards each other independently. Unification of semantics and notation to bring stability to object-oriented design marketplace. Anticipation that unification would improve better. So it can provide a better version than the earlier. So they had combined the three methods, and they given the unified version of the UML. So coming to the UML partners. Who are the partners of the UML? So the partners are Rational Software Corporation, IBM, Hewlett-Packard, iLogix, Icon Computing, Intellicrop, MCI System House, Microsoft, ObjectTime, Oracle, Platinum Technology, Tascam, Texas Instruments, Sterling Software, Unisys. These are the partners who have joined the hands with the UML. Next, coming to the next topic, the role of the notation. So what is the use of notation in the UML? So see here, the notation plays an important part in any model. It is the glue that holds the process together. Notation has three roles. That means, let's see one by one. It serves as the language for communicating decisions that are not obviously or cannot be interfered from the code itself. So by providing a language which can provide a communication decisions. So that is the main role played by the notation. And coming to the second one, it provides semantics. It means rules to the language that are rich enough to capture all the important strategic and tactical decisions. This is the second role played by the notation. And coming to the third one, it offers a form concrete enough for humans to release and for tools to manipulate. This is the third role played by the notation. So coming to the first one is, it serves as a language, and second one is, it provides the semantics. Third one is, it offers a firm concrete structure, so that will be very useful for the UML. The unified modeling language provides a very robust notation which grows from analysis to the design phase. Certain elements of the notation, for example, classes, association, aggregations, inheritance are introduced during the analysis phase. And other elements of the notation, for example, containment implementation, indicators and properties are introduced during the design phase. So this is how the notation is developed in two phases, in the analysis phase and the design phase. So coming to the benefits, UML can be applied to diverse applications like banking, finance, internet, aerospace, healthcare, etc. It can be used with all major object and component software development methods and for various implementation platforms also. So it means you know exactly what you are getting. You will have low development costs. Okay, by using UML, the development cost can be reduced. Your software will behave as you expect with fewer surprises, not a much. So the right decisions are made before you are given poorly written code. So it will reduce overall costs. We can develop more memory and processor efficient systems. System maintenance costs will be lower. So less relearning takes place. Working with the new developer will be very easier. Communication with the programmers and outside contractors will be more efficient due to the models which can give a single platform to all the stakeholders. UML attempted to standardize semantic models, syntactic notations and diagram of OOAD. Here, we use different terminologies like system, model and view in the UML. So what is meant by system? What is meant by a model? And what is meant by a view? Let's see in detail. Coming to the system. A system of elements organized to achieve certain objectives form a system. Systems are often divided into subsystems and described by a set of models. It means system can be divided into subsystems. Every subsystem can be described by using a set of models. Next one is model. A model is nothing but it is a simplification of reality. A model is simplified, complete and consistent abstraction of the system, created for better understanding of the system. Coming to the view. A view is a projection of a system's model from a specific perspective. So, if you gone through the drawing also, you'll be seeing different views like a top view, bottom view, side view, etc. This is how here also we use 5 types of views. I'll discuss about them in the later part of the unit. And coming to the applications of the UML. So, where the UML can be used. The UML is intended primarily for software-intensive systems. It has been used effectively for such domains as enterprise information systems, banking and finance services, telecommunications, transportation, defense, aerospace, retail, medical electronics, scientific, distributed web-based services. These are the applications provided by the UML. UML is not limited to modeling software. In fact, it is expressive enough to model non-software systems such as workflow in the legal system, the structure and behavior of a patient healthcare systems, software engineering in aircraft, combat systems, and the design of the hardware. Here also, not only in the software systems but also in the hardware field or non-software system also can be used this UML diagrams. Next, coming to the principles of modeling. The use of modeling has a rich history in all the engineering disciplines. That experience suggests 4 basic principles of the modeling. It means, first one, choose your model well. It means, the choice of the model profoundly impacts the analysis of the problem domain and the design of the solution. So, ER model is best suited for modeling databases. Structured system analysis and design method will yield an algorithmic centric solution. OOAD will yield object centered solution. So here we have taken for every object oriented concepts, we go with the OOAD diagrams. So we need to choose the models well. Next, coming to the every model may be expressed at different levels of precision. It means the same model can be scaled up to different granularities. So it means if you have seen the data mining, here you will be seeing the figures like operations like roll up, roll down. Here also the UML diagrams also provide such type of flexibility. It can provide a different levels of precision. Okay. So the bird's eye view is as important as the fine grained view. Means bird's eye view means top level view. So rather than sometimes if you go down in detail, it is better to go with the bird eye view. So different groups of interested parties will employ or use different views at different times. So based on the requirement of the user, we can go in detail or we can go in a brief view. So that's what UML can provide. Third point, the basic models are connected to reality. Simply the model but don't hide important details. Very often it helps to make simplifying assumptions, but in simplifying one has to do judiciously. It means correctly. So assuming a dedicated telephone link may be okay in some cases, disastrous in others. So this is how we need to use the models. The best models are sometimes connected to the reality. Coming to the fourth point, no single model or view is sufficient. Every non-trivial system has different dimensions to the problem and its solutions. So analysis and design have several dimensions: structural, temporal, behavioral. So a single model is hardly ever sufficient to capture all the design views of the system. So we need to have a large number of models. So these are the 4 points which we have discussed till now. These are given by the basic principles of the modeling. Okay, these are the basic principles, 4 basic principles of the modeling. First one is choose your model well. Second one is every model will be expressed at different levels of precision. And third one is the best models are connected to the reality. And coming to the fourth one, no single model is sufficient to show all the perspectives of the or dimensions of the problem. These are the principles of the modeling. We have seen the 4 principles. This is regarding the modeling aspects. And coming to the next one, object-oriented modeling. Civil engineers built many kinds of models. Most commonly, there are structural models that help people visualize and specify parts of systems and the way those parts relate to one another. Depending on the most important business or engineering concerns, engineers might also build dynamic models. Each kind of model is organized differently and each has its own focus. In software, there are several ways to approach a model. The 2 most common ways are from the algorithmic perspective and from the object-oriented perspective. The traditional view of software development takes an algorithmic perspective. Algorithmically, it means becomes hard to focus on as the requirements will be changing. If the requirements are changed, we can't do it. So algorithmic is nothing but the structural modeling of the system. Next, what we are using right now is object-oriented modeling. These models are most closely and related to the real-world entities. So this is regarding the object-oriented modeling.